welcome to the next episode of the Klingberg Wing Mark II development. I'm Raul Klingberg, your host. Today I'm going to be showing you how I made a test sample of a full-size Elevon torque tube. What you're looking at here in the photo is me partway through the process. I've prepped an aluminum tube that is 3/4 of an inch in diameter with the standard process that I use of overwrap of polyester on the tube and mold release so that I can get the carbon fiber tube off the aluminum mandrel. If you go look at some of my other videos on how to make composite tubing, you'll see that process. Also, you'll see that there is already one layer of carbon fiber on the mandrel. It is a piece of helically wound carbon fiber fabric that is in the form of a sleeve, and I've slid that over the tube already and wetted it out. And when the video starts here, you'll see me start working on the second layer. This tube is going to be 2 layers of this helically wound sleeving, and then it's going to be overwrapped with a dual helix, 2 spiral wraps running in opposite directions to create a piece of tubing that is extremely strong in torsion. And then finally, I'm going to add doublers to the ends so that the tube is strong enough to accept fittings where I can apply the torque and test the tube. So let's begin.
Anyway, I put in an order today for some bevel gears for the mixer of the controls. Just some gears to play with. One set of 3. And, oh, now there's a problem. You know, when it's, you push too hard, it starts to buckle the one that's underneath, that's a problem. Snake this baby down there. Get this guy spread out a little bit more. And when I get a bulge, I know I have a problem with the material that's underneath. If I back up a little bit, I can get that removed. Yeah, looks like I got that out of there. Work these down just a little bit more. I'm trying not to press too hard. The harder you press, the tighter it grips. And if it starts gripping too tight, well then you got yourself some problems. So let's get a little bit more on here. Need another couple feet to get down to the end. There's a little bit of wastage in this process, but I wouldn't say that there's any more material wasted than a standard rolled layup. I've done a lot of tubing, and there's always some wastage. What you don't want to do is spill drops of resin on the reel of the sleeve, because it will catch an edge and run through multiple layers, and you'll ruin yourself many feet of usable material. That's bad plan. As you may have noticed in my videos over time, there's nothing fancy here. I'm trying to build in using methodology and equipment and expertise levels that hopefully represent an average home builder. You know, not everybody has fancy equipment. Not everybody has decades of practice at doing this stuff. And I do want this final design to actually be buildable by your average home builder. So I try to work with minimal amount of equipment, and I try to use what I consider to be average skill level techniques. I know it won't be average for everybody, but that's life. I still got a wrinkle down here at this end. It's very interesting. Probably going to have to run the material up past this wrinkle here and take it out and then back the material up. this thing fully threaded on here, then I'll take care of that wrinkle that's underneath. Okay, I should have enough sleeve on here now, maybe. There's that wrinkle right there. I'll try to get back to that guy. Come on, baby, I hope you reach this time. Nope, looks like we got another wrinkle up in here. I'm beginning to see the problems with this particular process. Because there's a wrinkle that's dead nuts in the middle. I am not going to get that out of there, I don't think. Oh, there, I think it went out. Whew, got lucky. Got very lucky getting that one out of there. I watched somebody make tubing on YouTube using this braided sleeve material, and not surprisingly, they stopped at one layer. They said, that's as far as you can go with this stuff. It's one layer. I says, I don't know. I've done a tapered tube with pieces of this material, each one successfully shorter than the other ones. There, we've made it to the end. I made it to the end. And I've done 6 layers thick, and successfully. So now I can cut the end here, and I can run this baby back up here. Let's see if I can get it up there to where the wrinkle is. And then I'll take care of that little problem spot. There it is right there. And we just pull that back down that way. Get that wrinkle out of there, and then run this stuff back the other way. It'll be fine. Don't know if I'm getting video of any of this, but I guess that's the fun part of this whole thing. Huh? There we go. We have, let's see, developed another wrinkle down here. I don't know what it looks like. There it is right there. Try to work this down here incrementally so we don't do that again. There we go. We got all the wrinkles out. I do believe. Working extra up this way. There we go. This end is well wetted out already. And that's probably because this end went on first and picked up resin as it went along, and this other end is pretty dry down here. So that's going to take a little extra resin. Let's see, I got another little pull here. We're going to let that one go. That's a small one. Small flaw that any home builder might get. Okay, here we are, back with more resin. And a fresh pair of gloves. We'll finish wetting out this part here. Looks like I might have a couple wrinkles underneath in the middle here. I don't think they're going to be enough to cause any structural issues. So I get down here to where it's already wetted out. So there we go, there's enough resin on that tube. And now let's try the spiral wraps and see how that goes. A bunch of thin strips here. And a little tape on the end, so I don't have long strips, so they have to be like an inch or two overlap at the ends. I'll start down here and do me a nice, fairly steep spiral. That. See how, that's fun. You can see it's almost essential at this part of the process. The tube is very slippery to have this up on a pair of divots, a mandrel holder, so to speak. doublers for the ends here. We're going to put fittings. Make sure the fittings don't cause tear up. Let's get these wetted out a little bit ahead of time. Get a decent start on them. Shape the cloth, give me a nice taper at the end. By the way, I generally clean my scissors once or twice, get to use them again. But I get these scissors off of Amazon for $2 a pair, and after a while I just throw them away. Not worth the trouble. So, let's get the doubler on here. Get back in frame here. Let's get the popsicle stick out of the way. Note that the doubler is going over the top of the spiral wraps. That's to help lock them in place at the ends. It will help with the proper transfer of loads. You might think that having the spiral wrap over the outside is the same deal, but it's not. If there's anything wrong with the bonding process, you're going to end up with delamination possibilities, and hence less than adequate part that would fail unexpectedly. And unexpected failures are never welcome. We don't really want to, we love the parachute manufacturers, but we don't want to support them if we don't have to. No parachute usage unless it's pilot error. No parachute usage due to design problems. Let's make sure that every time we use an emergency parachute, it's the fault of the pilot. He's been doing aerobatics when he's been told not to. That's usually the case. I think most standard hang gliders are placarded against aerobatics, but people still go out and do them. Quite often pay the price. Of course, I'm a pilot also, but I do this design work. Try to do it accurately so that nobody has to use their parachute if they don't want to. And I've never run into anybody who says, "Oh man, I'm just dying to use my emergency parachute." That just never seems to come up for some reason. Wonder why. Okay, now one for the other end. Hi, I'm back today with the final torque tube. This is near full length. This is just under 8 feet long, and it is constructed to essentially full-size standards. There'd be each end would have a little aluminum fitting in here. It's going to have a fork on it that allows connection of the Elevon in on one end and the stub torque tube on this end that will lead down to the control stick. But this is essentially full length. It's within, a few inches of full size. The tube came out extremely strong in torsion. It is really stiff. As far as I can tell, this has plenty of torsional strength. There's no filling on it. I've left this one hollow. If I can get it around here, you can see it's hollow still. The doublers make it 4 or 5 layers thick on the ends. In the middle, we're essentially 2.5 layers thick. I was surprised though this. It is quite flexible, quite bouncy in bending, and probably a little bit more than I'd like it to be. There will be a bushing here and a bushing at each end that supports the torque tube as it rotates to prevent bending midway and causing control deflections. But I would still like to have it a little bit stiffer. This tube is currently 6 2/3 ounces for the 8 feet of length, including the doublers, which is spot on what I wanted for this component. So I'm happy with that. So now I have to figure out how to make it stiffer without making it heavier. And sometimes we can accomplish that with just how we use the materials and how we lay them up. The current layup that we have on this tube is a braided sleeve, another braided sleeve, so 2 layers thick, and then this spiral wrap in both directions. We have one going this way, one going the other way, and the spacing on the spiral wraps, I know it's going to be very hard to see in the video, but it's about that far apart. There's an overlap at that distance. So these 2 unidirectional being spiral wrapped on these 2 sleeves, providing superior torsional strength. However, because these sleeves are braided in a helical fashion, and these are wrapped in a spiral fashion, there's not a lot of lengthwise stiffness because the fibers just simply are not running in this direction. They're all running on a bias. So we can solve that in 1 of 2 ways. We can change the layup, the sequence, use the same amount of material, but apply it differently so that we get all of the characteristics that we want. So one option would be to use 1 braided sleeve like that, and then come in with the spiral wraps over that braided sleeve, and then overwrap it with unidirectional. In other words, this would go on the tube first, we'd do the 2 spiral wraps, and then I would come in with the unidirectional and just roll it like this around the outside. Now because this is unidirectional, we'd have a lot of stiffness lengthwise, exactly what we want. And this cloth is actually lighter than the sleeve, so the tube would actually be lighter weight. And that sounds terrific until you stop and think that when you apply a torque to the tube like this, there are resulting shear forces that develop in this direction like this. As you torque this way, you get shear this way. In order to resist that shear, there has to be fabric to stop that. Now you do have the biaxial woven sleeve here, and that would resist a fair amount of shearing. These don't do much for you because they're unidirectional on the bias, and these that are stiffening it lengthwise would do almost nothing for you. There's really nothing holding these sets of toes together, just a little scrim pieces here that are strictly for layup. There is no shear strength in this material. It is strictly for stiffness and bending, stiffness and strength and bending. So that is an option, but probably not the best one. So if we were to do this layup instead, the sleeve, the 2 spiral wraps, and then standard basket weave biaxially woven cloth, and we would lay that over the outside, and I would then just roll the tube, roll this around the tube like this. I don't have enough material here to show the full roll, but we go around once plus a little, and then we have a lot of toes that are running lengthwise that will provide the bending stiffness that I want, and then we have the transverse ones, which will be hoops, not spiral hoops, but individual hoops around the tube, and that will resist the shear that develops when the tube is put under torque. This fabric weighs a little bit less than the sleeve, so overall the tube should come out approximately the same weight. And there's another added benefit. What I discovered is that with the spiral unidirectional wrap over the sleeve cloth, I had a very difficult time getting the peel ply to wrap tight to the tube. And even though you probably cannot see it in the video, the surface is very rough here. It's irregular, very rough. Things catch on it. It's really not an attractive, well-done layup. I'm not pleased with it. And it's doubly bad here at the tapered ends, where this is thick here and tapers back down to the tube. Really hard time getting the shrink wrap and the peel ply to pull up tight and squeeze this together. I'm very unhappy with how this finished off here. So by going with the biaxial sleeve, spiral wraps, and then the basket weave on the outside, this basket weave will enclose, you'll have this, and then this. So the outside of the tube is all going to be essentially the same material. There will be some undulations to it due to the thickness of the material, but that's okay. This should lay up a lot better than this. We'll get all the properties we want for essentially the same weight. We'll get a stiffer tube lengthwise, same strength torsionally, I believe, close to it anyway. And Then, after the tube is cured, I will come back and add the doublers on the ends as a post-cure secondary bond. And when I do that, I'll be able to use very thin strips of peel ply and get this taper done nicely here where there aren't gaps and steps. Anywhere where there's gaps and steps like this, you're going to get a stress riser and get premature failure, very bad thing. So I will lay up the doublers on the ends on a secondary basis. The other thing that I should point out that was quite surprising to me, it's one of those things that when it happens you think, oh gosh, why didn't I see that coming? But you just don't think of these things. When these strips were laid up on the tube like this and wrapped around, everything looked peachy until I went to do the spiral wrap of the peel ply. And as I did the spiral wrap of the peel ply, well, one of these guys is fine if I'm wrapping the peel ply in the direction of this spiral wrap, but the guy that's laid up in the other direction began to buckle. As I put tension on the peel ply and tried to pull it tight to the tube, these were buckling up like this as I went along, and it was plainly put, almost a disaster. And that's part of the reason I have a lot of roughness, because I didn't pull the peel ply really tight to the tube, and it just not a very good layout. Once these are enclosed in the overwrap of the basket weave, hopefully that won't be an issue. I won't be, as I wrap the peel ply, I won't be pushing on this and causing buckling to occur. And I'll do a video of that layup, and I'll post that, and we'll see how it works out. So thanks, and coming, watching this part of the torque tube development. I think it's going to be a very effective drive system, lightweight, strong, and just what we need. So thanks for coming. Tell your friends to help support on Patreon, and come on back and watch some more. Bye now.